Now we are diving into decorators. They allow us to extend and modify the behavior of functions without changing their original implementation. They allow us to dynamically alter how functions work, adding new capabilities without modifying the existing code. Decorators support cross-cutting concerns like logging or timing, which would otherwise clutter our main code. They are a key component of Python's metaprogramming capabilities. Let's start with the higher order functions, which forms a foundation for decorators. This is a function that operates on the other function. In Python, functions are first class objects. This means we can pass them as an arguments to other functions, return them as values, and assign them to variables, just like any other object. Here we see a simple higher order function. Our function fun takes two parameters, a function f and a value x. We call function fun of square comma 5. We are passing the square function as an argument, which then gets applied to the value 5. This ability to manipulate functions as object is the foundation upon which decorators are built. In the example, our decorator function accepts a function as an argument and returns a new function called wrapper. The wrapper function adds behavior before and after calling the original function. When we call the decorated function, we are actually calling this wrapper. Notice at decorator syntax. This is the syntactic sugar for hello assigns decorator of hello. It's a cleaner way to apply the decorator to our function. Next, the decorator with arguments. Here we have a decorator that repeats a function execution a specified number of times. The structure is a bit complex. We have three nested functions. The outer function repeat accepts the arguments for our decorator. The middle function decorator is our actual decorator that takes a function, and the innermost function wrapper is what replaces our original function. When we use the repeat of 3, we are calling repeat 3, which returns a decorator which is then applied to our function. This pattern allows us to create highly customizable decorator for various use cases. By using the decorators, we can modify the function behavior dynamically, take existing functionality and enhance it, keep our code clean and reusable. Some common real-world applications include logging function calls for debugging, adding authentication and authorization checks, measuring the performance of critical functions, and implementing caching and memoization for expensive operations.